So I think we had left off on this slide. Does that look about right to you guys? That's okay. That's okay. All right. So in chapter 8, we've been talking about building towards probability. Before we can do that, we really need to talk about counting and specifically these sets. These sets are important because if we're looking at probability in terms of like outcomes and events, those things naturally form sets. So these rules for how we manipulate sets or count sets become really important to us. So given that U is the universal set and this is the empty set, if I take the intersection of two sets, oh, that's why it's not in the...
Can I go to the last one?
Yeah, of course. All right. So intersection between two sets is commutative, that A intersect B is the same as B intersect A. So the numbers that are, the set of numbers that are, positive and even is the same as set of numbers that are even and positive, right? That hopefully makes a lot of sense. Or the union operation is also commutative. So the number of, or the set of numbers that are even or positive is the same as set of numbers that are positive or even. The complement of a complement is just the set. So it's like a double negative, right? I'm not interested, which would mean you are interested, right? Just like a double negative. If I take any set and intersect it with the universal set, I get back just the set A, right? The universal is everything, and so it includes A, so the stuff that overlaps A in the universal is just everything in A. A union the universal, well, that's a union, so it's going to be everything, right? If the universal is everything, if it's A or everything, well, then we have everything. A intersect A complement. So what is the in common between the set of dogs and the set of not dogs? Nothing, right? So this should be empty, right? If I take the intersection of a set with its complement, that should be the empty set. How about the union? What's the set of dogs or not dogs? Should be everything, right? And then we have two other properties that have a special name. They're called De Morgan's laws. So if I have A union B and I take the complement of that set, that's going to be A, or not A intersect not B. So like the complement distributes through, but it changes the or to an and. And if I did it with A and B, and then I take the complement of that, I get not A or not B. Everybody's okay with that? Essentially, the complement distributes, but it changes your ors to ands and your ands to ors. Just flips that symbol. Okay. So let's look at an example. 2 tetrahedral dice. Tetrahedral means Four-sided. What's a four-sided die look like?
Yeah.
Nope, that has six sides.
Triangle.
Like a pyramid, right? The pyramid has three sides on and then a bottom, so that's the fourth side. So we have two four-sided dice with sides numbered 1 to 4. One dice is blue and one dice is yellow. And we roll them. We want to find, or we define the set T as at least one dice lands on a 3. So what are the outcomes there?
One, 1, 2, 1, 3, 1, 4, and then just so on.
1, 1.
Isn't there 2 dice?
Yeah, but at least one dice lands on 3.
Oh, 3, 1, 3, 2. 3, 3, 4.
Yeah, so close. That's half of it because the two dice are colored. So we have the blue dice comes up 3 and the yellow dice comes up 1, 2, 3, or 4. And then the yellow dice comes up 3 and the blue dice could come up 1, 2, 3, and 4, but we've counted one outcome twice. All right, so we did this, right? So if we count this up, what do we have here? 1, 2, 3, 4, 1, 2, 3. So there's our set. Everybody's okay with that? What if the blue set B is the blue dice lands on a 3? What will that set be? Just this column, right? Where the blue dice is a 3. Everybody's okay there? And again, notice that we chose to put blue as the Y value and yellow as the X value, but there's just a, like how you wrote that or how you define that. The order of the numbers is purely dependent on the construction we made here, right? You could write this as like Y1, B3, Y2, B3, Y3, B3, Y4, B3. Probably be how I would write it, where I would designate the yellow and the blue next to the number. But, okay. The sum of the dice is 6. There's just these 3 right here, correct? 4, 2, 3, 3, 2, 4. Okay. Let's run through these in-class examples, and then we will stop, and I'm going to check in IA data or IA calculations, and that'll be that. Sound okay? Oops. Come on over here. All right, suppose that exactly 5% of a specific type of cell phone under warranty will be returned, and the cost to replace the phone is $150. If the manufacturer knew which phones would go bad, they could charge a $150 warranty for those phones and $0 for the rest. However, the manufacturer cannot know which phones will end up needing to be replaced. If the manufacturer wishes to be as fair as possible, how much should the manufacturer charge every customer for the warranty? What do we think? How much of that $150 should each person be paying?
Same amount. 30%.
Yeah, because you don't know who's going to have a defective phone and who won't in advance, right? That's impossible to know. If it was possible to know that, then you would just not make the defective phone. You'd fix it before it left the plant. Let's think about this. How many phones should we have to sell in order to expect one of them to be defective? %5 is what as a fraction? 5 out of 100. If you reduce that, you get 1 out of 20, right? So I'd expect out of every 20 phones sold, one of them would need to be replaced. Everybody's okay with that? So that $150 replacement fee, I would want to split amongst those 20 people. And that would ensure that every 20 phones I've sold, I have a replacement fee covered by the warranty, right? Everybody's okay with that? So how would I determine how much I should charge for my warranty? 150 divided by 20, or 150 multiplied by 0.05. Either would be okay. That comes out to be $7.50. Everybody's okay with that idea? Now, in practice, as a manufacturer, are you going to charge $7.50 for the warranty? No, you would charge more, because what happens if you catch a string of bad luck and you get yes, 5% of the phones over time are defective, but the first run of them, maybe 15% of them are defective. You need to make sure that you've covered enough up front to where you're not losing your profits, and because of you got an uncharacteristically bad batch of phones go out or something. All right. Example 2. Roll a die 12 times and record the results. We've rolled a die 12 times and recorded the results of each roll. Which of the following outcomes is more probable? Why do you think it's a trick question? Exactly right. That's correct. Both outcomes are equally likely. Everyone's okay with that? How many outcomes are there of this situation of rolling a die 12 times? 6 to the 12th, right? There's 6 outcomes for each of the 12 rolls, so you have 6 times 6 times 6 times 6, 12 times. This is just one of those If this was all ones and this was random, still the same probability of an outcome, right? Because it's just one outcome. Everybody's okay with that? Okay. In casinos, there's often a large display next to every roulette table showing the outcomes of the previous spins of the wheel. The results of the previous spin have no effect on the results of future spins. So why do casinos use these displays? What's that? When you say they, who do you mean? Okay. Yeah, it's to trick you as the gambler, right? Into thinking that, oh, red's come up 6 times in a row. I'm going to bet black. I'm getting an edge. You're getting no edge. The probability has not changed. Give the probability model for flipping a fair coin 3 times. You may list your sample space in whatever manner you wish. So when we say the probability model like this, what do we mean? Want all the outcomes, right? How many outcomes should there be? 2 to the third, right? There's 2 outcomes for a coin flip, head or tail. You're doing it 3 times. That's 2 times 2 times 2. That's 8, or 2 to the third. Everyone's okay there? All right. List them then. Those 8 outcomes.
All heads.
So like,
All tails. Like 2 heads, 1 tail.
when you say 2 heads, 1 tail,
Oh, I just ignored it. I just do head, tail,
okay?
and then tail, head,
Okay.
head, tail,
Okay.
tail, tail.
And then head, tail, tail. That's all 8 of them. That was kind of tough though, right? Because you didn't really list it very systematically. My suggestion, or the way I like to do things like this, is so I have head, 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 and then I have head, head, tail, and then I have head, tail, head, and then I have head, tail, tail. Those are all the outcomes where we can start head, right? So now we'll do the outcomes that start tail. So we'd have tail, tail, tail. You can have tail, tail, head. You can have tail, head, tail. And you can have, is that it? 1, 2, 3, 4, 5, 6. Okay, there's one more. What was it? Tail, head, or tail, head, head, right? Yeah, that's it. There it is. I don't know. Something like that. So here we have all the integers from 1 to 10 as our universal. When I say inclusive, what's that mean? Including the number 1 and the number 10. Everyone's okay with that? A is the even numbers between 1 and 10 inclusive, and B is the set 2, 3, 5, 7. Anyone recognize that set? Those are the primes, prime numbers between 1 and 10. So draw a Venn diagram that relates the sets above. So the first thing you'd want to do is draw your box and put a U in the corner indicating that's the universal. Draw a circle for A and B. And now I like to fill in the intersection first. What's going to live in the intersection there? 2. That's the only thing that's even and in B. So the other things that live in B should be 3, 5, 7. What are the other things that should be living in A?
4, 8, 10.
4, 6, 8, and 10. What haven't we listed anywhere yet?
1.
And? So those live somewhere outside. Is that okay with how we drew that? Easy to forget these ones. Don't forget them. Okay. Use the Venn diagram below to shade the following sets. That's a good one. So not A Everybody's okay with not A? Here is not A or B. What's up? So this is the way I think about it. A union B is this, right? Everyone's okay? That's A union B. If I do not that, everybody's okay? Okay. A intersect not B. So this is getting a little bit more complicated. Let's shade A. And then we'll shade not B. So what's our intersection of the two? The green. Everyone's okay with that? Okay. How about not A union B? So let's shade not A. And then let's shade B. I'm going to shade them the same color because it's a union rather than an intersection. Everybody feel okay? How about not A intersect B? So start with the inside like we did before. That's A intersect B, right? Want everything except that. Everybody's okay? It's the way I think about them. Yeah? We have 1 million of these, huh? Okay. There are 40 students at an IB school that are studying either chemistry, biology, or both. 25 students are studying chemistry, 19 are studying biology, 4 are studying both subjects. Represent the above information as a Venn diagram and as a two-way table. How many students are studying just chemistry, and how many students are studying just biology? So I'm going to start with my Venn diagram. Put my little U here. I'll do C for chemistry, B for biology. Okay, what goes in the intersection? 4. Why did we put 4 there? For studying both. Okay, how many should we put in the rest of the C?
25.
Well, 25 are in the C circle. How many are currently in C, though?
4.
4. So how many more do I need? Everybody's okay there? And then how about the rest of the B?
15.
Okay. If I add these up, what do I get? I get 40, right? So there's nothing left because we had 40 students, right? So there's nothing outside. Okay? So that's my Venn diagram. Everybody's okay with how we constructed that? So our two-way table, let's do chem on one side and bio on the other. So we're biology and not biology, chemistry, not chemistry. Oh, we should probably have a total column. Okay, what goes in this box here?
4.
4, because we have 4 that are in biology and chemistry. How many are in chemistry and not biology?
21.
How many are in biology and not chemistry?
50.
How many are in not biology and not chemistry? 0. So if I add that up, I have 25 total in chemistry, and I add that one down, I have 19 total in biology. That makes sense. And I just add the rest of the rows and stuff, and everything looks pretty good to me. Notice here that those other totals gave us those other parts of our Venn diagram, right? Okay. Let's do another. There are 50 people in a band. The conductor wants to know who can play the saxophone, who can play the trumpet, and who can play the drums. He finds that 2 people can play all 3 instruments. 5 people can play just the saxophone and the trumpet. 1 person can play play the saxophone and the drums. 3 people can just play the trumpet and the drums. 22 can play the trumpet. 15 can play the drums. 18 can play the saxophone. Represent this as a Venn diagram. How are we going to need to draw this Venn diagram? Hopefully it feels pretty natural that I'm going to need 3 circles. What are the 3 circles for?
7. function traits.
Okay. What goes in the triple intersection?
2.
2. 5 people can play just the saxophone and the trumpet. So that 5 goes here. Notice that it's just the saxophone and the trumpet, so they can't play drums also, so it doesn't count the 2. So we did that one. One person can play the saxophone and the drums, or just the saxophone and drums. 3 people can play the trumpet, just the trumpet and the drums. 22 people can play the trumpet. How many people do we have currently playing the trumpet? 10, right? So how many go in the rest of the T? 12. 15 can play the drums. How many do we have currently playing the drums?
6.
So how many in the rest? And then how many people can currently play the saxophone? So the rest of S is 10. Are we done?
No.
We still have to see if there's any of the 50 people that can't play anything, right? So let's count this up. I have 10, 15, 17, 18, 21, 30, 42. So I'm 8 shy. Why are you in the band if you can't play anything? I don't know. Maybe you're just looking for that easy A, right? I don't think it'll be that easy if you can't do anything, but okay. Look, how many people, we already answered that, right? Okay. What does this mean? If we have a little N in front of that, set, S union T. That's the number of things in that set. So S union T is that, right? Everybody agree? So 10 plus 5 plus 12 plus 1 plus 2 plus 3. So 15, 27, 33. And then what's the P here stand for? That's the probability, yes. So what's the probability that you are in that set S union T? Well, how many, that's going to be the number of things in S union T divided by the number of things in the universal. How many things are in S union T? How many things are in the universal? So you'd write that as, you could leave it as 50 or 33 out of 50. You could write as 66%. You could write as 0.66. Take your pick. All of those answers are fine. So far, so good? All right. I think this is the last example. Yeah. Okay, good. There are 105 people in the same grade as each other. The teacher finds out that some students are in the same math, science, and English classes. She finds that 4 students are in all 3 classes together. 12 students total are in math and science together. 5 students total are in science and English together. 9 students total are in math and English together. 40 students total are in math. 26 total students are in science. 50 total students are in English. Represent the above information as a Venn diagram. What should this Venn diagram look like? A triple, yeah. So U for universal, math, science, English. Okay, what should go in the triple intersection? 4. And we have 12 total are in math and science together. So what should go in this other part of the math science intersection? 8. Notice that the vocab here is different, right? It says 12 total as opposed to 12 are in just math and science together. Okay. We have 5 students in science and English together. So what goes over here in the rest of science and English intersection? 1, because we already have 4 in the triple. And then 9 students total are in math and English together. So what should be in the rest of our math and English intersection? 5. Is everybody so far so good? We have 40 students total are in math. How many currently in math or in the math circle as we've placed it? 17. So how many more need to be in math? 23. 26 total are in science. How many currently do we have in science? 13. So how many more need to be in there? 13. And then 50 are in English. How many do we currently have in English? How many more do we need? Let's count them up. 23, 31, 44, 49, 54, 94. So I have 11 more that need to be somewhere else. They don't have any classes together. So we did that. Right? Ooh, find the number of students in not math intersect English. So I'm going to do this with some shading, and then we'll count afterwards. Sound good? So I'll shade not math. And then we'll shade English. And we'll use different colors. So what's in our intersection then? 41. Everybody agree? Okay. So, oh my goodness, Mr. Kulik, this looks insane. It's not so insane. So here it says find the probability of M union S intersect not E. So again, let's do the shading. Of course. So M union S is that part, right? Everybody agree? I use the same color because it's a union. Now I'm going to do intersect not E. So let's shade not E. So I see that that is 44 things. You guys feel okay there? So again, you're rewarded by visualizing here, right? That's how I'm doing all this stuff, is I'm just like using the Venn diagram that I've drawn and kind of visualizing what's going on. The next one is, ooh, Boise, is not S intersect not M and then union E. So I'm going to draw the intersection here with some color. So we have not S and then we have not M And then we have Union E. So if I count the green, I have 40 plus 5 plus 4 plus 1, and then plus that 11 out there over 105, or 61 out of 105. You guys feel okay there? All right, so at this point, I'm going to stop the recording. You guys should be able to work on section 8.1, which is page 259 to 262, 1 through 15. And I'll just be calling you up one at a time to show me your calculations. Okie doke? All right. In the meantime, you can work on your IA or work on this problem set. Please try to do one of those two things, though. Thanks.